doesn't look like a pinwheel. But the connection between this pulley and this bar is a pin. There's a pin connecting these two. Connections are things, or supports. Supports and connections are synonyms. Supports and connections are ways to connect one thing to another. So if this was a pinwheel, I could blow it and it would start to spin. It's considered a two-dimensional. So if we look here, pin, where's pin?
Very top.
At the top. Here's a pin, and there's an ideal pulley on here, so there's the exact example of what's on top. So let's see, is it 2D or 3D? So which things do not apply at all? Which columns do not apply for a two-dimensional item?
Force in the Z,
Force in the Z,
moments in the X.
moment in the X, moment in the Y. So I'm drawing lines through them. And I'll put a line down on the bottom as a legend, does not apply. Does not apply. So now, thinking about a pinwheel, the possibility is a force in the X. Can this pulley move relative to this bar, or can that thing that's the blade that's spinning on a pinwheel, can it move in the X direction relative to the stick? No, it resists it, right? Force X. Does it resist a force in the Y? Yes. Does it resist a spin? No. So to summarize these three, how many reactions are at a pin support? How many reactions are at a pin support? 2, and what are they? Force in the X and a force in the Y. Okay, and how do we communicate that? If you look at this picture for a pin, and I'm going to cross this one out. Here's a pin. Does everybody see the pin there? It's usually just a circle. What does it resist? It resists a force in the X and it resists a force in the Y. Does it resist a rotation? No. No, so it's not drawn. Only the reactions at supports are drawn. Why? That's what I have to worry about, because that's where failure might occur. And I don't know if your mind has gotten here before yet, but in statics, what we do is we solve for those unknown forces. As engineers, don't we want to know what force it's going to experience in the X and the Y? Don't we want to know what that force is? Because if it can only take 10 pounds, I'm not going to subject it to 100 pounds, because then I'm going to break that connection, right? And if I can calculate what the reactions are at the supports due to all the external loads on it, I could choose a heavy-duty pin that won't break. Right? Okay, so let's go to the other one we looked at, ball and socket joint. How many reactions are at that support? 3. What are they? Fx, Fy, and Fz. And what do? We draw. Where is it? Ball and socket, here. We draw them. We draw those forces. Remember when I said there are times that we don't know which direction the force is going in? Is it going in the positive X or the negative X? We don't know, so we just draw it, and then if we get a negative, we know it was the other way. We have to draw them because we have to calculate what those forces are. When it's free to move, it's not going to fail in that direction. It can take any kind of moment, and it's going to be cool. It's never going to break. And then for the hinge, how many reactions are at the hinge support? 5. forces and 2 moments. And then you would have to draw them. And let's look at the hinge here. Here's the hinge, and sure enough, they drew the 3 forces, and then they drew the 2 moments. So it's important for us in statics, when we're first being introduced to connections, to be comfortable with the most popular connections that are used. And they're all on this table. So a pin, a fixed support, a collar on a smooth shaft with a pin, collar on a smooth shaft with a fixed support, ball or roller or rocker, a pin and a smooth guide, ball and socket, hinge, journal bearing, thrust bearing, ball bearing, smooth pin and bracket, and fixed support. We need to be comfortable with all of these. Okay? I think the best way to be comfortable with them is to either be able to see them in your own person, or something like the door, or you have a whole bunch of connections. So here, this is for group 1 and 2. The reason that the covers are on here, so you don't scrape up the tabletops. I don't mind if the boards get scratched.